we're back. Okay. So we're on the second page. I notice in the second page we're dealing with missing angles. So all of these, and there's only one type of problem here. So we're not gonna. So we're dealing with missing angles. So I'm gonna pick this one right here, 15. And that's the one I'll show you. So again, we're pairing up these two and these two. So now though, I'm going to have sine of 119 over 45 equals the sine of x over 20. So I'm going to cross multiply still. 20 times the sine of 119 equals 45 times the sine of x. So I'm going to show you a slightly different way to do this one. Now I'm going to do it twice. So I'm going to do 45 here, and then I would go 20 times the sine of 119 divided by 45, and I end up with 0.389 equals the sine of x. Now, sometimes people, especially when we're multiplying and dividing, they get a little overwhelmed with the whole sine thing. So if I sat there and hit sine 119 on my calculator, it would give me 0.875, 0.8746197071. I'm going to round to 0.875. So what I can do is I can actually switch that out, and I can go 0.875 over 45 equals sine x over 20. Then when I cross multiply, I get 20 times 0.875 equals 45 times the sine of x. This will give me 17.5 equals 45 times the sine of x. And I divide by 45. And lo and behold, I get 0.389 equals the sine of x. So, look at what I did here. I said that the sine of 119 equals 0.875. Now that is true the other way around. If I said, what angle has a sine of 0.875, I could put that in my calculator. I could hit second sine, or inverse sine, depending on what calculator, of 0.875. Well, it would give me 61, but that's slightly different. So I picked a bad example to do that with. Anyway, when you ask your calculator for sine and cosine, it's always going to give it here. So it's 0 to 90. So 119 is out here. And notice that that is 21 away from 90. So 90 plus 21 is 119. 90 minus 21, because it would then continue in a circle all the way around. 90 minus 21 is 69. Anyway, sorry, 29. 90 minus 29 is 61, which is what we get if we do the inverse sine. But anyway, so that took a weird little turn that hopefully just didn't confuse the heck out of everybody. Okay, here, let's do 49. 49 works. So if I hit sine of 49, even if I round it, I get 0.755. Now if I hit second sine, 0.755, bloop, I get 49. And that's because this number, the sine of, is that. And it's important to realize that when we're talking about sine, cosine, and tangent, these ratios are constant. So when we get something like this, and we can't divide by sine, that doesn't work. So what we do is we hit second sine, or whatever your calculator has that as, sine to the -1 power of 0.389. And that's going to give us 22.9. Now over here, if we did 20 sine 119, enter, divide by 45, enter, and then we go second sine, second dash, hey, look at that. We get 22.9. Now the decimals are a little bit different, but both of these end up being 22.9 degrees. And that's the important thing, is that they're the same when rounded to where we need them to round to. So, again, the problem I just did, number 15, that's basically the exact same pattern you're going to use for 9, 10, 11, 12, 13, 14, 16. When it comes to these first 8, you want to use number 1 as a model for 1, 2, 3, 4, and number 8 as a model for 5, 6, and 7. Have a great weekend, everybody. I'll see you all on Monday. Actually, I won't, because Monday is a holiday, so I'll see you all on Tuesday.